Hey everyone, so welcome to this deep learning episode 3 stochastic gradient descent episode actually. So in first two lessons I'm already added in the description and that below actually, so you can just go through once and you can come back to this episode 3. So after that you can get some better understanding from there. So in first two lesson we'll learn how to fully connected networks out of stacks of dense layers. When first created, all of the networks weights are set randomly. That network doesn't know anything yet actually. So in this lesson we are going to see how to train a neural network. We are going to see how neural networks learn. So as with all the machine learning tasks, we begin with some set of training data. So each example in the training data consists of some features actually. So along with that expected target as a output and some feature I'm already said, right? So that's the input. Training that network means adjusting that weight such a way it can be transformed that features into the target actually. So previously we taken that some food related data sets, right? So in that such as cereals like sugar, fiber, protein, and content like that. In that we successfully trained the network to do that, and its weight represented some way of relationship between the training data, right? So in additional, we have a training data with we need two more things actually. So one is loss function and the another one is the optimizer actually. So a loss function that measures how good the network's prediction are, and the optimizer that can be tell network how to change its weights actually. So this is the major thing we are going to talk in that video. So let's deep dive into that. We have seen how to design an architecture of for a network, right? So but we have not see how to tell a neural network what problem to solve. So this is the job of the loss function. So the loss function measures a disparity between the target's true value and the value to the model predicts actually. Yearly, the different problems call for the different loss function, right? So we have been looking at the regression problem where the task is to predict some numerical value. For example, calories, 80 cereals, right? So in that video, we are going to take that some data set called red wine quality. So in that other regression task might to predict the price of house or the fuel efficiency of the car, right? But a common class function, the regression problem is mean absolute error. So that called us, we can see that, let me take, and so in that, I can take us MAE actually. So that's called mean absolute error. So this is the kind of regression problem. For each prediction, we have a, for example, that mean absolute error, we have a y prediction, and also MAE measures the disparity of true target, that is called y true, y true, and by the absolute value difference between that, as you can see that. So in that Python we can use that ABS, and in that, so y true along with that y prediction. So the total MAE loss, that means that mean absolute error loss on a data set, is the mean of all those absolute differences actually. The mean absolute error is an average length between that fitted curve and the data points actually. So besides that MAE, other loss function you might to see for the regression problem, mean squared error actually, MSE, or the hub loss, both available in the keras actually. So that is the major thing. So that you might see that another regression, that thing, so we can call it as a mean squared error. So that is MSE and the hub loss actually. So high chill. So hub loss. So both available in that keras actually. So first you need to learn that theoretically, then you can implement as a theoretical using keras, tensorflow, this kind of things, deep learning libraries actually. So during the training, the model will use the loss function as a guide for finding the correct value of its weights actually. Lower loss, it's better. Yeah. In other words, the loss function tells the network it's a objective. So as you can see that mean absolute error, so in that there is a true and there is predicted value. So as you can see that, so it will be neutral actually. Some of the times it will be getting more accurate, and some of the things it will be getting some loss values actually. So this is how that mean absolute error is average length between that fitted curve and the data points obviously. So this is how that loss function value works. So the next thing we can go with that the optimizer actually, the optimizer for that stochastic gradient descent actually. We have described that problem we want the network to solve, but now we need to say how to solve it. So this is the job of the optimizer. So that optimizer is an algorithm that adjusts the weight and the minimize the loss actually. Virtually all the optimization algorithm used in the deep learning belong to a family called stochastic gradient descent. They are iterative algorithms that train a network in steps. One of the training goes like that. So the first thing is sample some training data and run it through that network and to make the prediction. So this is how, and measure the loss between the prediction and the true values. That's the second one. And the third one is finally adjust the weights and the direction that makes the loss smaller actually. So this is how that steps are running in that model actually, algorithm level. So then just do this over and over until loss is small as you like it actually. So the training network with the stochastic gradient thing, as you can see that fitted line and training loss and weight. So these are the three methods I just sent it over. I just told over there. So each iteration sample of data is called as mini batch. So while complete round of training data is called as epoch actually. That number of epochs you train is how many times in the network we'll see in that each training example actually. So let me show some deep actually. So each training actually, so that each iteration sample of training data it's called as a mini batch. So mini batch, while complete round of training data is called an as a approach actually. So we have a model, and in that we have a huge sample data actually. So like some sample some training data and run it through the network and to make the prediction. So this is how that our idea. So in that part, while complete round of training data is called an approach actually. So as you can see that, so complete round, so training data is called as approach, because that deep learning freshers will it get some confusion about that approach thing actually. So that approach means the complete round of training data is called an approach actually. The number of approach you train is how many times the network will see that each training example actually. So uh, as you can already see that in that animation, that linear model from that lesson 1 trained in that sgd actually, and the that pale red dots depicts that entire training set, while the solid reds are actually that mini batches actually. So every time sgd sees a new mini batch actually, it will shift the new weights actually, that is called w. And towards that means w means already you know that slope, and b is that y intercept actually. So towards their correct values on that batch, batch after batch, the line eventually coverages and it's the best fit actually. You can see that loss as it gets smaller, weights gets closer on their true values actually. So this is how that optimizer will it works on that stochastic gradient descent level actually. So the next thing we can see that learning rate and batching size as well. So we'll go that. Notice that that lines only makes a small shift in the direction each batch actually. So that size of these shifts it's determined by the learning rate. A smaller learning rate means that network needs see more mini batches before its weights coverage to their best values. The learning rate, that size of mini batches are two parameters that have a largest effect how SGD training proceeds actually. That means the stochastic gradient descent. Their interaction is often subtle and the right choice for these parameters is not always obvious. Fortunately, for most work, it won't be necessary to do that extensive hyperparameter search to this get satisfactory results actually. Consider as a Adam is an SGD algorithm and that has adaptive learning rate actually that makes it suitable for most problems without any parameters. Adam's a great general purpose of optimizer actually. So in that the next part that important thing we going to adding that loss and optimization in our model in that TensorFlow keras actually. So we'll go that. So in that we are going to see that how to add the loss and optimization in that keras and TensorFlow code actually. So after the defining model you already know that how to define the model. So if you don't know that, so you can just look into that our previous videos. I'll add it in the description below in the link actually. So after that defining the model you can add a loss function and optimization with the model compile method actually. So the model compile, you can get that you can assign the two parameters, optimizer and loss as a string. Optimizer is a Adam and loss is a MEA actually. So this is how we are going to introduce that. Actually, MEA already you know that mean absolute error actually. And notice that we are able to specify that loss and optimism with just a string. You can also access these things directly through the Keras API. If you want to tune the parameters, you can do, but for us, it works defaultly. Well, it works fine actually. So coming to the code part, now we know everything. We need to start the training deep learning models, right? So let's see in the action. So we'll be using the red wine quality data set, and so I can open that red wine quality data set as well. So here is my data set, actually red wine data set. So in that, as you can see that each wine, each red wine, how much of fixed acidity and volatile acidity and citric acidity, residential sugar, chlorides, sulfur and total sulfur, density, pH, alcohol quality. So all those things will it there actually. So this data set consists that physiochemical measurements actually from about that 1600 and Portuguese red wines actually also include that quality of rating each wine from that blind taste actually. So how well we can predict that wine perceived quality from the measurements. We have put all the data preparations into the next utensils. It's not essential that it what follows, and feels free to skip it. But one more thing, this is how we are going to discuss in that lesson 5 the neural network tend to perform, which when their inputs on the common scale actually. So in that I'm going to predict that some of the things actually. So I'm going to add that that loss and optimization in that keras code using this data set for this data set. And let's go with that coding part actually. So this is that. So first I can import that pandas and as a pd and ipython as for the display, uh, f- just for the reference actually, but that second one is it's optional. So the next part I can just read that that redwine CSV using pandas pd.read CSV. So the data frame will have in that redwine variable actually. So in that new part, so we are going to create a training and a validation the splits actually. So first we have a redwine data set data frame. So in that, so what I do is, so in that data frame, we have a red wine data frame. So in that, I can get the sample of fraction zero point 0.7 and the random state of 0. I can assign it so I can get the samples over there for the red wine, and it will be go to the data frame train object actually. And I have another thing, data frame valid. So in that, the same thing, red wine drop and df train dot index actually. So in that, it will be truncating that invalid data actually. So after that, I can call it that ipython display object, so that the class. So in that class, I can first take that four headers, that four columns of the redwine.csv actually. So after that, I'm gonna apply that scalable thing 0 1. So in that, first I can taking that maximum of axis 0. So in that, df train dot max axis 0. So it will be returning that scalable of axis 0, that max value of max and the minimum value of minimum, it will be returned. So after that, I'm doing some calculation, df train minus minimum, and also the same as maximum minus minimum, and if I divided that, it will be getting that data from the train, and same as df valid actually. So this is how it will be validating that scale 0 to 1. So I just scaling that data actually. So in that next step, first that actually what we doing is, we are clean upping the data actually before training these things actually. So in that first, that last thing, we can split the features and target actually. So as we already know that that dense and split all those things, right? So the same as we have a x train and x valid and x y train and a y valid. So based on that, we can drop the quality, and we can take the quality to that y train and y valid actually. So after that, we have here some cleanized data. So first, I am going to take that things, and first I am going to from tensorflow, and in that I can import that keras actually. So that same thing, can say that tensorflow keras, and in that particularly I can take that layers actually. So this is how yeah, it's going to work actually. So I can keep it like that actually. Yeah. And the next thing, so I have a model. So that model keras, and sequential. So in that, this is the sequential class. So in that, I'm going to define the array. So in that array, I'm going to create multiple layers actually. So the first layer, layers dot dense. So in that dense, actually 512 layers. Along with that, activation should be a relu. Activation should be a relu. And the input shape, that means we have 11 inputs, right? So input shape should be a 11. Okay. So this is how will it going to work. And the next layer, same as dense 512, the activation relu actually. And the next thing, same as layers, I can create multiple layers based on that. Oops, my bad. Activation relu. So I'm already put the video for that creating layers and what is relu, what is input shape, like that actually. So you can go through once again for the previous videos. Thank you. So and So designing that architecture of your model should be part of the process. Start simple and use the validation laws as your guide. You'll be learn more and more development in the exercises. After that, defining the model, we compile that optimizer and the loss function actually. So in that, I'm going to put say model we have. So in that, I'm going to add that some more features in the compile state. So in that, the first thing optimizer, so that is Adam, and the loss optimization should be a margin activation error actually. So MAE, so that I can add it actually. So this is how simply we can add it that both things in that part. And yeah, obviously, so we can easily to add those things in that compiler method actually. So now we are ready to start the training actually. So we have told to Keras feed the optimization 256 rows of the training data at a time actually, that batch size. And to do that at a 10 times all the way through the data set actually, that approaches actually. So in that we have a 256 rows. In that I'm going to do that 10 times all through the data set actually. So in that I'm gonna take that function called fit function in that model. So in that I'm gonna type history variable. So in that model dot fit, so in that inside the fit object, so I can choose x train and y train. So that is I added. So after that validation data, and in that x valid and y valid, so that I can add it. And batch size should be a 256, and the approaches should be a 10 times. I'm going to get that actually. So after that, once the compile will started, so after that it will be starting that approach thing. So in that, how much loss and how much value loss, and each time we did get returned that actually. So and as at the time you can see that Keras will keep you updated that loss as the model trains actually. Often a better way to your loss through that plot it actually. The fit method in a fact keep the record. Loss produced during the training in a history object will convert your data into the pandas data frame, which makes a plotting it's very easy actually. So this is the thing I want to share to in the video actually. So how that model compile will it works, and how we add the optimizer and loss method in added in our model actually. So hope you guys you will get some basic understand of that deep learning, building a proper model actually from that using tensorflow and keras actually. So hope you guys you really like that video, and if you really like that video, please subscribe my channel for more videos like this in the future. And don't forget to subscribe my channel. And thank you all. We'll see you on the next episode. Bye. We hope you found this video informative and helpful. If you did, please hit the like button and consider to subscribe our channel for more videos like this in the future. Also, don't forget to share this video with your friends and colleagues who might find it useful. If you have any questions or comments, please leave them in the comment section below, and we'll be happy to respond. Thank you for watching. We'll see you on the next video.